So right now I want to talk about section 10.6, inverse trig functions. Suggested exercises are 11, 31, 51, 71, 131, 141, 166, and 167. So there are answers for the evens, so 166 has an answer. The main topics are like arcsine, arccosine, and arctangent, although we also have the inverse functions for secant, cosecant, and cotangent. I'd like you to look at examples 1 through 4 and 7 in the book. Okay, so diving right in, the function sine inverse, also known as arcsine, I'll say sine inverse of x, also known as arcsine of x, is the inverse of the sine function. Now, obviously sine can't have an inverse because it's not one-to-one, but it's the inverse of the sine function restricted to the domain. And we're going to restrict the sine function to the domain negative pi over 2 to pi over 2. And what this does is it's going to give us all the possible output values of sine. So when we do the inverse, we've got a one-to-one function to work with, essentially. Similarly, arc cosine of x is cosine inverse of x. The inverse of cosine, but now over the range or over the restricted domain. So for cosine, we're going to go from 0 up to pi, and this is going to give us, of course, every possible x value. Finally, tangent inverse is also called of x is also called arctan of x. Is the inverse of tangent of x restricted to the domain. And now this is going to basically be like sine, except we're going to lose the endpoints. Negative pi over 2 up to pi over 2, losing the endpoints. Let's just draw a quick sort of picture so we can see what we're talking about here. So to get all the x values, we're going to go from negative pi over 2 up to positive pi over 2. So we've got all the angles going up this way, all the angles coming down this way. That's going to give us all the possible sine values. All the x values, all the cosine values, are going to start here at 0 and go all the way over to pi, including the endpoints. Now again, tangent is not defined for a vertical line. We don't have the definition of a slope. So it's going to be basically the same as the sine range, except excluding these endpoints. And that's going to be our range for cotangent. All right, so let's just do some simple examples. Find arctan of 1. Okay, arctan of 1 is solution. What's the angle? That has tangent theta equals 1? Well, it's pi over 4. So that's our answer. Arctan of 1 is pi over 4. Okay, let's try a different one. Find tangent of cosine inverse. So this time I wrote arctangent for the inverse of tangent. Here I'm writing cosine to the negative 1. Oh, and just note for all of these, but I'll just write it for cosine. So cosine negative 1 does not mean 1 over cosine. Okay, this is very important. It's unfortunate notation that the raising to the negative 1 power always means 1 over, except in this instance. Sorry about that. If I could have done things differently, I would have, but this is what we're stuck with. So this is tangent of cosine inverse of 1/2. So what we're going to do is find, so what theta has cosine of theta equals 1/2? Well, that's going to be pi over 3. And that's because cosine of pi over 3 is 1/2. So our final answer is tangent of pi over 3, which is, of course, square root of 3, and that's our final answer. So I hope that made some sense. Best of luck.